A dietitian in a hospital is to arrange a special diet containing two foods, Health Bar and Power Bar. Each ounce of Health Bar contains 30 milligrams of calcium, 10 milligrams of iron, 10 IU of vitamin A, and 8 milligrams of cholesterol. Each ounce of Power Bar contains 10 milligrams of calcium, 10 milligrams of iron, 30 IU of vitamin A, and 4 milligrams of cholesterol. If the minimum daily requirements are 360 milligrams of calcium, 160 milligrams of iron, and 240 IU of vitamin A, how many ounces of each food should be used to meet the minimum requirements and at the same time minimize the cholesterol intake? And we're letting X equal the ounce of Health Bar and Y equal the ounces of Power Bar. So we have a lot of different types of information here. We have calcium, iron, vitamin A, and cholesterol. So let's organize this in a table. So X is Health Bar, and Y is Power Bar. And we have calcium, iron, vitamin A, and cholesterol. So the Health Bar contains 30 milligrams of calcium, 10 milligrams of iron, 10 IU of vitamin A, and 8 milligrams of cholesterol. So that's going to be my first column. And then the Power Bar contains 10 milligrams of calcium, 10 milligrams of iron, 30 IU of vitamin A, and 4 milligrams of cholesterol. So that is my second column. And then my totals, it says the minimum daily requirement is 360 milligrams of calcium, 160 milligrams of iron, and 240 IU of vitamin A. So because it's the minimum, these have to be greater than or equal to those numbers. And then lastly, I'm trying to minimize the cholesterol intake. So this is what we're trying to minimize. Next, I want to translate these into equations. So these are going to be my coefficients of my x's, these are my coefficients of my y's, and then these are going to be on the other side. And because this is min, this is going to be my objective function. So I'm trying to minimize 8x plus 4y. So that is my objective function. And then the other three are my constraints. So 30x plus 10y is greater than or equal to 360. 10x plus 10y is greater than or equal to 160. 10x plus 30y is greater than or equal to 240. And then because this is real life, x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So these are all of my constraints. And I'm going to want to graph these, so I need to isolate for y in each of these three inequalities. So the 30x plus 10y is greater than or equal to 360. I want to subtract 30x from both sides. And then divide everything by 10. So y is greater than or equal to negative 3x plus 36. This is one of my lines. Now let's look at the 10x plus 10y is greater than or equal to 160. I want to subtract 10x from both sides, and then divide everything by 10. So we get y is greater than or equal to negative x plus 16. And then we're looking at 10x plus 30y is greater than or equal to 240. So I want to subtract 10x from both sides, and then divide everything by 30. So y is going to be greater than or equal to negative 10 over 30 reduces to negative 1/3. And then 240 divided by 30 is 8. So y is greater than or equal to negative 1/3 x plus 8. And then lastly we have y is greater than or equal to 0. So now we are ready to graph these equations. So if we go to the y equals, this is negative 3x plus 36, negative x plus 16, negative 1/3 x plus 8, and 0. And if we look at the 36 here, we know that that line crosses the y-axis up at 36. So if we go to the window command, I'm going to go a little bit further than 36 and pick 37 for my x-max and my y-max. And then if I press graph, this is what my graph looks like. So now I'm ready to do the shading. And I actually like to do the reverse because I think it's easier to see. So each of our inequalities were actually greater than or equal to, but because I'm doing the reverse, I'm actually doing the lower shading on each of these. So if we graph that, this is what our graph looks like. So our feasible region is this region right here. So this is actually an unbounded feasible region. Next, I want to remove the shading so that it's easier to find the intersection points. So I need to go back to the y equals menu and change all of these back to the line symbol. And then if we press graph, this is what our graph looks like. So before I actually find the intersection points, I want to go back to my paper and draw the graph first. So it's going to look something like this. So I have to find this point, this point, this point, and this point. And this is my feasible region. So I'm ready to find the intersection points on the calculator. And I'm skipping a couple steps here in this video, but if you want to see how to do the intersection command and all of the steps with the first curve, second curve, and guess, you can refer to the previous videos where I go into detail about that. So my intersection points are 10, 6, 12, 4, which is actually really close to that, 24, 0, and 0, 36. So I want to label those corner points on my graph. So 0, 36, 10, 6, 12, 4, and 24, 0. So those are my corner points, and those will be our candidates for the minimum. So we need to plug those into the objective function 8x plus 4y. So 8 times 0 plus 4 times 36, we get 144. 8 times 10 plus 4 times 6, we get 104. 8 times 12 plus 4 times 4, we get 112. And then 8 times 24 plus 4 times 0, we get 192. So the minimum value here is the 104 at 10, 6. But lastly, we need to put this into context of the problem. So our final answer will be the minimum is 104 milligrams of cholesterol at 10 ounces of Health Bar and 6 ounces of Power Bar.